This video introduces us to the interval, and specifically we're going to be describing how functions behave by using these intervals. An interval limits the domain of x values that we consider for a given function. Or in other words, it's going to allow us to look at just a small portion of a graph. Some examples of an interval where we could limit the domain of x values are shown below. If we see this interval in red, this expression, it's telling us to only consider the x value when it is greater than -8 and less than 2. Or in other words, only consider the function when the x value is between -8 and +2. We won't look at anything else if x is bigger than 2 or if x is something a lot smaller than -8. We wouldn't be considering those parts of the function if this were the interval we were looking at. Another one would be when x is somewhere between 2 and 5, when x is greater than 2 and less than +5, that's what this blue interval is describing here. Intervals are nice because they allow us to describe complicated functions by describing what happens during a limited part of the graph. We see a complicated function here. For a while it's increasing in a straight line, for a while it's constant, and then it's curving down in a nonlinear way. So intervals would allow us to describe what's happening in this function. We could look at the red stretch. Here x goes from -8 all the way up to +2. So we would say for this interval, x is somewhere greater than -8 but less than +2. What's happening to the red line during this stretch? It has a positive slope. We could say that it is an output that is increasing. As we continue to move, the output goes from -3 to -2 all the way up to a +2 at the end. So we have a positive slope where the output is increasing. During the next stretch, the blue stretch, we see x is going from 2 all the way up to 5. So we could limit that domain, or this interval could be described when x is somewhere greater than 2 but less than 5. And what's going on here? We have a slope of 0 at this point. The output is remaining constant. So it doesn't matter, the entire time during this blue interval the output is 2 the entire duration. It's got a slope of 0, it never goes up or down. Finally, we could limit the domain for the green stretch. We see x is going from 5, and by the end of the green stretch, or at least when the graph runs out of room, we're up to 10. So we could say the domain there is limited when x is between 5 and 10. We could really even say to infinity with this arrow. We could say x is going from 5 to infinity. And during that whole time, as soon as x is greater than 5, we could simplify that to say whenever x is greater than 5, this function is decreasing. It has a negative slope during that time. First it's decreasing slowly, and then it's going more quickly. So we could have a negative slope, or the output is decreasing during that time. We could say more about these stretches. During the green stretch, we said it was decreasing slowly at first, and then it speeds up, it curves. So we could say it's a nonlinear function during that interval. But for the blue and the red ones, we see this straight line, a constant rate of change, first a positive constant rate, and then a rate of 0. We could say it's a linear relationship only during this limited domain from -8 to 2, or a linear relationship when we're limiting the domain for x anywhere from +2 to +5. So that is how we can use intervals to describe or answer questions about what's happening for a complicated function that keeps changing its rate of change.